This week on Quality Digest Live, we'll find out how to convince students about the benefits of careers in manufacturing.
That's right. Plus, the most significant change to the international system of units in more than a century. That and more when we come back. And welcome back to Quality Digest Live for December 7th, 2018. QDL is your weekly look at who and what is making the news in the world of quality. I'm Mike Richmond, publisher of Quality Digest.
Yes, you are. And I'm Quality Digest editor-in-chief, Dirk Ducharme. So you did or did not hear the news about the gene-edited embryos that became babies kind of thing?
No,
did you hear that story?
I know a little bit about this, but I don't know this particular story that you're talking about. I know the general idea, yes.
Okay, so last week one of the really big news items was, and this is according to Associated Press and others, a Chinese researcher claims that he helped make the world's first genetically edited babies, twin girls born this month, whose DNA he had altered with a powerful new tool. You've probably heard it's called CRISPR, which allows you to directly edit genes, directly edit DNA.
But CRISPR works with like viruses. I thought.
It can work with anything. You can edit genes. You can edit DNA, right? So, but
gotcha.
so a lot of research being done for editing viruses and stuff like that. But if you can edit DNA, you can edit DNA, right?
True. Okay.
So, so what he did is he by the way, his name is He Zhangquai. He's in Shenzhen. So what he said is that he altered the embryos for 7 couples during fertility treatments, and then those embryos were implanted into the mom, and then at least one pregnancy resulted thus far. And he said his goal was to give the babies an ability to resist possible future infection with HIV. Now keep in mind, these babies did not have HIV, nor did their parents have HIV, so there was no, and this is part of the big storm that's coming up about this, there was no real reason for him to do this other than, people are saying, other than experimentation right? on humans, right? So there's a lot of ethics issues, there's consent issues, there's procedural issues. A lot of people said even his procedure wasn't done very well, but that's not what I want to talk about. What I want to talk about is now the genie is out of the bottle. Consumers want whatever it is they can get, and now he has shown, maybe, nobody's actually verified that he actually did this, he just claimed he did it, but certainly the technology is there to do it. And so this is raising all sorts of issues. I'm sorry, even if you're going to make it illegal, if you're going to say, well, you can't edit genes, for the purposes of, just preventing something, there's got to be a really valid, people are going to do it.
Oh, yeah.
People are going to do it. Consumers want what consumers want. So the question is, so what do you do now when what consumers want, or very likely some consumers will want, is to be able to tweak their babies to be, red hairs with freckles?
Well, yeah. Or get rid of that.
Or maybe
let's
not
ever have this.
Or never get white hair. I don't know.
Never go gray. There's something. Never go bald. Well, we actually did cover this in a special report. I wrote an article that kind of touched on some of these issues as well, the ethics and the morality of the biology space. And it's a difficult one because, you're right. Consumers want what they can get. As this evolves, it's going to become easier and easier for people to even we talked about things like an app store essentially for genetic coding. You can go on and just pick whatever you want for your kid or for yourself. And there are a lot of questions with that. One thing you have to understand is the difference between ethics and morals. Morals are basic, inherent ideas that you get about what's right and wrong. Ethics are rules essentially that are created by external organizations saying, okay, well, this is what we do. Now, you need both in this space, really. You need the ethical approach to say, you need the moral approach to say, well, is this right or wrong? You also need a framework. And the right or wrong part of this, you're never going to be able to control because it's individual people to do that. If it can be done, it's going to be done in the name of profit, experimentation, curiosity, whatever it may be. But the ethical part of this, I think, is where the solution is going to come, where you're just going to need rules, frameworks for it. I mean, you think about nuclear power. I mean, potentially nuclear power could be used for a lot of ill will.
It has.
It has, but it also, it has a place in energy production and whatever. I mean, so there's a framework around that controls it, so that it's less likely to be used for bad purposes and more likely to be used for good purposes.
Yeah, the thing with nuclear power, though, is that it's in nuclear energy is that it's very hard to do and very expensive to do. Whereas something like CRISPR is easier, and I mean, there's obviously skill involved, but it's not. It doesn't require billions of dollars like nuclear energy does, right? I mean, the tools are out there, and the tools are relatively inexpensive. So now, I mean, you really are opening up, like you said, the genie's out of the bottle. And so what do you do now? I mean, obviously you can put laws in place, but then you start getting this gray area. So, suppose you have the ability to edit a gene so that a baby won't be born with a particular type of birth defect, okay? Or maybe a disease, maybe cancer, something like that. So if it's okay to go in and say, well, it's okay to edit, and to keep somebody from being born with a birth defect or something, which a lot of people might say, well, yeah, that's a good idea.
Of course, yeah.
Well, where do you start drawing the line, right?
I don't want any children that are below 5'6".
Exactly.
Children that have a nose that's too big, or that have bad eyesight, or whatever. I mean, you alluded to gray hair, or whatever, freckles, gray hair. I mean, there is really no line at that point. I mean, you start having design. I mean, it's probably inevitable that you're going to have this ability to edit and design the features that you want, the physical features that you want.
Right.
The technology is there. I mean, the question is there a will amongst the people of this world to stop that? Can you stop it? I mean, it really probably can't be just stopped in its tracks, but you can say, well, this isn't something that we want, so we're not going to embrace it. We're not going to create ethical frameworks that make it acceptable. It's going to be considered to be outside the normal, acceptable.
And we'll end on this. My thought is that some years down the road, this is going to be, and I could be wrong, I think this is going to be the abortion issue of the future. Because it starts to tread on kind of the same thing. You're what is life, and when can you start, or when is it right, or is it ever right to diddle around with it, right? And I got a feeling that in the future, this is going to be the abortion issue of the future. I think.
Yeah. Well, I mean, it's not life or death. I mean, in a certain sense.
Well, true. You're right. But it's still in a sense, some people would say it's kind of all playing God.
It is, and that, again, it goes back to morals. What are the societal morals that prevent that from happening? Is it frowned upon or not? I mean, abortion is not. It's accepted to a certain extent, but many people look down upon it. And say even if you're a pro-choice person, you say, well, I'm pro-choice. There should be that choice available in society. For me personally, I wouldn't want to make that choice.
Right.
But the choice itself should be available. So. It is an interesting analogy that you use with the abortion issue. These are complicated issues, man. And the article that I referred to in my piece talked about the wild west of this, and that we've just started. I mean, this is really just going to get wilder and weirder and more confusing and complex as we go. So we'll keep an eye on that one going forward.
All right,
thanks, Derek. All right, well, in a recent article, convincing students that manufacturing job skills will pay off, Caroline Preston of the excellent Hechinger Report website examines the ways that young people find manufacturing jobs, or perhaps more accurately, the way that manufacturers find employable young people. So allow me to explain what I mean, Derek.
Explain.
This is an interesting,
explain it to me.
An interesting thing that Caroline's talking about. Now, it's become old saw to say that not every high school student should pursue a four-year degree, right? Sure. I mean, we hear about that all the time. Yep. But the reality is that, as Preston exposes in her article, and she sheds a lot of light on it, is that the skills that are translating into solid careers for this forthcoming generation of students, of kids and workers, really need to be developed, and you really need some support educationally to give them those skills. the story she's talking about takes place in Janesville, Wisconsin. Janesville, Wisconsin, an interesting little town. By the way, it's the hometown of Paul Ryan, current Speaker of the House, right. Ironically, the outgoing Speaker of the House. And Janesville is an interesting place. Of course, it's right in the heart of the old Rust Belt. And like many towns and cities that are in the industrialized Midwest of the United States, it's dependent on labor in the manufacturing industry, and it's particularly in automotive. Okay. General Motors had a plant there that successfully employed many, many people for many decades. It closed in 2008. Now, of course, we all remember in 2008 there was a major problem in the automotive industry. So what happened there, of course, like it did for many communities, unemployment soared into the double digits very quickly. 8 or 10 years ago following that. Now, since then, more manufacturers have entered into the area. Now, unemployment now in the area is 3.3%, which is pretty good, low. However, a lot of the jobs that are being filled are in relatively low-paying service industries or retail, food, things like that. So manufacturers that are moving into the area, they're actually really crying out for skilled workers, the people that can do those jobs. And the question is why? Why are they crying out for the skilled workers? Well, one expert quoted in the piece, and his name is Peter Capelli, and he's a professor of management at the University of Pennsylvania's Wharton School. He says, quote, employers have stopped training. They want people who already have the skills and already have the experience, and no one wants to give them the experience. Right. Talking about a catch-22.
Catch-22, yeah.
I mean, they're saying, well, we have these jobs. These good jobs are available. And Preston kind of talks about it. She gets into the weeds a little bit on this. I mean, you look back a generation in the GM plant that closed. She quotes a figure of $28 an hour that unskilled labor was getting working in that plant in those days. Right. $28 an hour 10, 20 years ago.
Right.
It's a lot of money.
It's a lot of money.
Now, of course, we know why, because the labor unions negotiated that for those workers. But those are good jobs. If you make $28 an hour without a college degree, you can support a family on that. Sure, absolutely. That's a good job. But now when those jobs went away and what came in were jobs at McDonald's or Target or whatever for 10 or $12 an hour, you can't support a family on that. There's no way. You can maybe stitch together 2 or 3 of them at once, but guys are going to work 60, 70 hours a week making 10 or $12 an hour. I mean, it's not feasible. And the conundrum there really can be solved, but it needs to be solved by partnerships and people working together to solve it. And Janesville is doing that through their public school system. An example is the Parker High School that Preston quotes in the article. Preston High School in Janesville is offering really interesting coursework. They're offering coursework on things like marketing and business, computer science, robotics, health and human services, agriculture, manufacturing, and a lot more. And to make sure, this is another interesting piece of this, to make sure that the high school teachers there are equipped to provide the skills that the kids need, they instruct their teachers, Janesville School District, to get master's degrees. And they pay for it. They pay for them to get master's degrees at technical colleges. That's pretty sweet. They don't pay for books, but they pay for the actual tuition to get the master's degrees, which is pretty cool. The courses themselves have very specific goals. They prepare these kids with real world skills, including critical thinking skills, which is really important. And that's going to give them something other than a choice between those, again, $10 to $12 service jobs or the crushing debt that you're going to get from a 4-year degree. I mean, many times that's the choice. You say, well, I'm either going to go $50,000 in the hole on getting a 4-year degree, or I'm going to maybe have to settle for a 10 or 12 or $15 an hour service job out of high school. There's not a lot in the middle. And this really goes to the heart of a question that we've talked about a lot on the show. Is it a wage gap or is it a skills gap? Different people will argue different ways about that. And it's been going on for a while, but I think once the workforce has the skills, if what Janesville is doing works out, and I think it will, and they provide more workers with those skills, we're going to find out if it's a skills gap or if it's a wage gap, because the manufacturers are either going to step up or they're not. And I mean, they in a certain sense, if there's more people with the skills, it probably supply and demand would say that maybe they'd be able to maybe give less. But certainly they're saying, hey, we've got these jobs available. We're going to pay X for them. We can't get them filled. Well, if the people are there that can fill them, well, they should fill them, right? They should give those people those jobs. The other big question here is, and this to me is really the key issue, who's responsible for getting those jobs filled? Who's responsible for making sure that industry has the workers they need? Is it industry themselves? Is it the educational system? Or is it the individuals themselves, even if you're 15 or 16 years old?
Well, I'd say yes.
All the above.
All the above, right.
But that last piece of it is one that I think people don't think about enough, is that even if you're 15 or 16 years old, you've got to understand nowadays that you're in charge of your own career. You have to be looking at things like this and taking advantage of these opportunities. You can't, I mean, when I was that age, I didn't really know that well, but I had a sense that I was going to go to a 4-year college. But if you don't know, you really should be investigating these things. There's a lot of opportunities, not just in Janesville, but in a lot of school districts to find this kind of education.
I understand what you're saying, but I don't think most 15 or 16-year-olds are going to, unless they're led.
Or their parents.
Unless they're led by the teachers or their parents. Yeah, because I mean, 15 or 16-year-old, you're only thinking about, one or two things.
Well,
one thing.
but you know what? You're right. Of course, you're right. But I would argue that I think in other countries they do this. In other countries, you have kids in India and in China and in Europe even, where they are
kind of groomed
a little bit more to say, listen, you got to be thinking about this from a younger age. I'm not talking about 8 and 9-year-olds, but I mean, STEM education can really go down that far too.
Right.
But I mean, you need to understand that as an individual, it's your career. Eventually, it's going to be your career. If you're not in your career yet, you've got to be responsible for it.
Yeah, got to be thinking about it. And like the educational system and we see more and more anyway. Manufacturers themselves, industry itself, is kind of like stepping up, and we keep talking about this, the growth of apprenticeship programs and stuff in order to.
That's a great one too.
In order to build up your workforce.
Everybody's got to get involved, but education system, the individuals, and the manufacturers all have to partner on doing that.
That's right. There you go. Okay, well, there was some other, we talked about some big news right at the top.
Earlier,
There was some other really big news this month, middle of November exact, and you can be excused if you didn't catch it. Although, this news actually affects every single person on the planet.
Whether you
I think,
know it or not.
whether you know it or not, one way or another, it affects you. And the big news is delegates representing countries, 60 countries, 58, 60 countries, voted last month in Versailles, France, to implement the most significant change to the International System of Units, the SI, in more than 130 years. For the first time, all measurement units, this is the big news, listen, all measurement units will be defined by natural phenomena rather than by physical artifacts.
Do you hear that?
Right? It's great news, right? All of you? Come on.
Crickets.
Anybody? Bueller?
This is important news.
This is important news. This is really important news, particularly in our industry. The event was the 26th General Conference of Weights and Measures and was hosted by the International Bureau of Weights and Measures in France. They're the ones who kind of oversee everything related to weights and measures.
Ever since the meter convention.
Ever since the meter convention,
130
years ago. And the big part of the announcement was that soon all measurement units, weight, length, time, temperature, what have you, will be based on physical constants. Now, as most of you know, it used to be, it's been quite a while, but it used to be all measurement standards were based on actual physical things. So there was a meter standard, and it was a standard, a physical thing that existed, and this was the meter standard upon which all other meters in the entire world were based on. There was a time standard, there was a weight standard, we'll get to that in a little bit. There was a physical standard for everything. Over time, we were able to kind of base those on physical constants. So for instance, the meter is no longer based on the meter, it's based on light. It's based on the distance light travels in a period of time, right? And what else? The time. The second is based on the cesium atom, the oscillations in a cesium atom. So many oscillations, billions of oscillations, exactly equals 1 second. Okay, so based on physical constants that never change. Well, the holdout has been the kilogram. For 130 years, the kilogram was defined as the mass of a specific physical object, a shiny metal cylinder, pucky kind of thing that since 1889 has been stored in a vault on the outskirts of Paris. But now the kilogram also will be based on a physical constant. It's going to be based in part on Planck's constant, and part of the vote of the 60 delegates last month was to actually set Planck's constant to a specific value. You know, they finally had to decide, okay, you know, how many decimal places and what is this thing going to be? So Planck's, and I won't read it here, there's actually 6-point change plus times 10 to the minus 34th meters squared kilograms per second or something like that. Anyway,
Wow.
that is actually what Planck's constant, and they all have agreed, okay, that is now going to be Planck's constant. And from this fixed value, scientists can derive the mass of a kilogram. So you're asking, how do they do that? Well, I wish I could explain it really well, but I'll give it a try. It goes something like this. Deep in the bowels of NIST's laboratory in Gaithersburg, Maryland, is something called the Kibble balance, or Watt balance. Yeah,
there it is.
That was really good timing.
That's great.
It's a very strange looking thing. It looks like a steampunk thing. And what this does is it equates the mechanical energy exerted by the mass of an object, the thing being measured, with an equivalent amount of electrical energy. So it equates mass, the unknown, and velocity, gravitational pull, magnetism, and electricity, all of which were based on physical constants. So there's 2 steps in this thing, the way this thing works. And I hope I'll get this somewhere in the ballpark of being right. First of all, there's a weighing mode, and that's exactly what it sounds like. A test mass, kilogram for instance, is placed on a pan that is attached to a coil that within a magnetic field. And it exerts, the mass exerts a downward force, gravity, and the current is applied to the coil and adjusted until the upward force, like electromagnet, right, is precisely equal to the balance of the downward force. So you got this mass coming down, and you got this electromagnetic force pushing it up, and when it's exactly equal, they measure the current that is recorded in order to keep that magnetic field at the point where it equalizes the mass. Okay, so that's the first part of it, and they measure that current. But there's some steps I'm leaving out here now. But that this also needs to be calibrated. So there's a second step in this process, in which the coil that we're talking about is moved through the surrounding magnetic field at a carefully controlled velocity, and the resulting induced voltage is measured, and then all that data is plugged into an equation, and voila, you have the mass of that thing. Okay, so the thing is, all these other measurements, gravitational force, velocity, current, etc., are all based on physical constants as well. So the entire process is done utilizing physical constants in order to determine a mass, which of course then itself is going to be based on physical constants. So now we no longer have the need for Legrand K, it was called. It becomes kind of a doorstop now. We don't need it anymore because we now have a way to determine precisely what a kilogram is using physical constants. And it's much more accurate than having, even though this was pretty accurate, maintained its accuracy pretty well, it was constantly losing mass for various reasons because it's a physical thing. It's not going to stay the same forever, right?
Exactly.
But physical constants never change. So if you can base mass on physical constants, which what the Watt balance allows them to do, now you have something that is should never change. And the only thing you can do is improve the accuracy with which you're taking these measurements. So obviously every time you're making a measurement, whether it's current or gravitational force and all that, you still need the accuracy in doing those things, and the equipment needs to get more or less accurate. Will get more or less accurate, more accurate. But you're still measuring physical constants. You're not measuring a hockey puck. Right. So the resolution will take effect on May 20th, 2019, and at that point, along with a few other resolutions, all measurements will be based on physical constants. So no more artifacts. There we go.
That's really cool. Good job,
it's
man.
pretty cool.
You did a great job explaining that.
Yeah, I don't know if it was accurate, but it sounded really good.
No, it sounded great. But this is something they've been working on for quite some time.
For a long time, yeah.
And this idea.
And the Watt balance has actually been around for a long time, but it was getting more and more accurate.
Yeah. So. But it's interesting because this has been a known issue for quite a number of years, decades, and that I think that scientists were groping for a better way to do this for quite some time, and this is a much better solution because again, you wouldn't think that an iron bar, or whatever
iridium, palladium, something like that. Yeah.
But you say well, that's not going to degrade. It does degrade to
Platinum
a very tiny, imperceptible degree to the human,
Yeah. Well, I think I read somewhere that it is lost about 50 micrograms 50 micrograms
Yeah.
Of weight, or is varied 50
Which
micrograms.
Is essentially nothing, but I mean...
Well, it used to be essentially nothing.
Yeah.
And the problem is, more and more they're needing more and more accuracy.
Yeah.
So they need 50 micrograms is too big anymore.
Right. That's right.
Too much of an error.
It's really interesting. So good stuff there. All right, thanks, Rick. Okay, we got a couple minutes here for off script. This is one that I've thought about, and I think that I'm curious about your take on it. It's been a crazy year. I mean, it's been a lot happened this year, 2018. We're coming up to the end of it, of course, and I don't know that we're really going to have a chance to do an off script. We have some busy shows coming up, so this might be the last time we have a chance to really do this. So I wanted to ask you, like I say, we've seen so much this year, so much has happened. What this year in quality, in manufacturing, in business, in society in general, what surprised you this year? What did you see wherever, at IMTS or at CMSC, or and you went to France, or you went to Italy, right? This year, and you saw some
Scotland.
The other Italy. Was going somewhere.
The other Italy.
That's right. You went to Scotland. So I mean, you had a lot of experience to see different things this year. What surprised you? What jumped out at you when you think back at 2018? I've got some things, but what did you see that you thought about that really said this is different?
Well, I think there's two. I'm still intrigued with 3D printing and 3D printing with metals. And to me, and we saw some more at IMTS, is this additive manufacturing method, 3D printing, and doing it with metals and getting a surface finish that in some cases, depending on the application, doesn't need a finishing operation. In other words, they can 3D print a part, and depending on the application, sometimes very precise applications, just take the part out of the printer and use it. That's just kind of mind-blowing in a way to me. It's particularly the surface finish bit of it. And I've seen some surface finish parts where the surface finish looks very, very much like nickel. So it's not shiny, it doesn't look like, a polished piece of stainless steel, but it's pretty darn shiny. And that kind of surface finish is perfectly fine for a lot of applications. The other one is just kind of the quickly growing use of autonomous vehicles. I'm still intrigued with that, and that is growing by leaps and bounds. I still think it's growing faster than most people have thought it was. Is being accepted more and more. They just opened up in Arizona. I think Arizona, one of the rideshare companies is now officially using autonomous vehicles, and we're going to see, and that's. A couple companies have done that, but we're seeing that roll out more and more. So those kind of two things that really leap to mind for me.
I mean, the things that I thought about were one thing we talked about when we were in Chicago was the idea that we saw so many more robotics in the quality pavilion this year than we had in the past. And the continuing penetration of industrial Internet of Things into really quality 4.0, I guess, for lack of a better term, really into the quality function, test and measurement function. We're really seeing a lot more of that automation in there. The other thing is kind of analogous to your idea of the autonomous vehicles is the workforce. And I mean, when we think about autonomous vehicles, to me, I think about, all the jobs that are going to be going away from that, and automation really affects that really very much. And going back to Caroline Preston's story, this idea that, are we training young people to take to do the jobs of tomorrow? Are those jobs even going to be there? I mean, people can have the skills, but if the model changes so radically that people, doesn't matter what skills they have, because any human skill is not as good as a machine skill.
Right.
That's an issue.
Well, something you just said, and I didn't think about this when you were talking about Carolyn Preston's story. I know a few people. My niece is one. My director is another. I'm sorry, my nephew is one. Our director is another, who are, and I haven't actually talked to Chris about this, but I suspect, I know the case with my nephew, have moved their kids from public schools into, let's say, charter schools that specialize in technical fields. Now, part of that is just an interest in that, right? But the other thing is because I think, at least I know on my nephew's part, he knows that's where it's going. That's where the skill set is. So I mean, he's got a son who's really interested in technical stuff, and he's not getting that fulfilled at his regular public in his public school. So, and that's where his interest is, and that's kind of where the jobs are going to be in the future. And so he moved him into a charter school, and his kid's thriving and loves it, and he's learning all this techie stuff. And because that's kind of, charter schools all have usually they're centered around specific topics. That might be art, it might be tech, it might be whatever.
Whatever it is, yeah.
But I'm wondering if that is a trend. I'm wondering if more and more parents are moving their kids from public schools into charter schools. And if that's true, is that raising red flags for the public school system going, maybe?
Well, I mean, or are we creating a bifurcated educational system where the kids that can go to a charter school, can afford to have the opportunities, get a better education than those that are in a public school?
In a public school.
Maybe in an urban environment. Yeah. It's an issue.
But it still says something to the public schools, is that, I mean, if this is indeed happening, and I've got 2 data points, so what do I know? But I wouldn't be surprised if there isn't a certain amount of that. And also just basically what Carolyn said is, if the need is out there, it's got to be you got to start fulfilling that need earlier on, which means an increase in what you're covering in terms of practical stuff at the middle school and high school level.
Yeah, exactly.
Yep.
All right, good stuff there.
Yep.
All right, well, thanks, Dirk. Good job on that off script, man.
Okay.
All righty. Well, that's going to do it for this week's Quality Digest Live. Before we go, we want to let you know that Quality Digest and the good folks at 3D Systems are teaming up to bring you a really interesting technical webinar next week titled The 3 Keys to Effective 3D Scan-Based Inspection. And the presentation happens on Thursday, December 13th, 6 days from now, at 2 p.m. Eastern, 11 a.m. Pacific. Tom Charon's going to be your presenter, and Dirk right here is going to host. So keep your eye on your email inbox for more information about how to register. If you haven't done so already, we've got a few people registered for that already.
And also there is a link on the player page down below there. You can click on that link. That will take you out to the registration page as well.
Check that one out. It's gonna be a good webinar. You talked about 3D printing. I mean, that's what a lot of the 3D Systems folks do. This one is a little different element of what they do.
3D Systems. Yeah,
they do a lot of stuff.
They do a lot of stuff based on 3D. Yeah, printing and inspection.
Inspection as well. Yeah. So that's our show for this week. You all have a great weekend. We'll see you next week here at Quality Digest Live.
So long.
Bye.